Okay, so we've got some questions here. We're going to talk about polygons in this case. So as soon as we see regular polygons or questions involving polygons like hexagons, pentagons, all those kind of shapes, then we should be thinking polygon, straight-sided shape, where there's an interior angle, and we can extend the edge to make an exterior angle. And we know that those two angles are going to add up to 180, and we also know that if it's a regular polygon, then the exterior angle equals 360 divided by n, the number of sides. So it says the exterior angle of a regular polygon is 36. How many sides does a polygon have? Well, from this formula here, we can see that we can replace the exterior angle with 36. We've got 360 divided by n, the number of sides, and we can see by rearranging this that n can be found by doing 360 divided by 36, so 10 sides. And a 10-sided shape would be called a decagon. A regular polygon has 9 sides. Work out the size of the exterior and interior angles. Okay, so we'd write down, because it's a regular polygon, we'd write down the rule. So exterior angle is equal to 360 degrees divided by n. So for this shape it would be 360 divided by 9, so 40 degrees. And because the exterior and interior meet at the vertex of the polygon, that's the exterior, then they're going to add up to 180. So the interior angle would be 180 minus the 40 degrees, so 140 degrees. There is another way of getting the interior angles. There's a formula for doing the sum of interior angles for all polygons, and that's n take away 2 times 180. So for a 9-sided shape, we'd be doing 9 take away 2 times 180, and then divide by 9 because we wanted one of them. So 9 take away 2 is 7. So 7 times 180 equals, and then divide that answer by 9 equals 140 degrees. Can't be any different to the other method. It's just another way of getting the answer. So 3 formulas to do with polygons then. If it's regular, then the exterior angle is 360 divided by n. The interior plus the exterior angle will always add up to 180 on any polygon, and the sum of the interior angles, the inside angles, will always be found for a polygon, any polygon, whether it's regular or not, by doing n take away 2 times 180. Okay, so angles in polygons, practice them, your exam board likes them. Okay, this next question then is talking about some rope, and it creates a right angle triangle, although it's not being shown. I suspect that's a printing error. That would be a right angle. It's a vertical wall, so it's kind of giving you a clue that it's 90 degrees anyway. Okay, so it asks us to work out the length of the rope. So 12 meters away, the rope is attached there, so this is our missing length. And basically we can see a right angle triangle with an angle given and a length. It's kind of shouting out at you to use trigonometry. So there's lots of methods for doing trigonometry, but we tend to think of SOHCAHTOA, so the sine of the angle, the cosine of the angle, sine of theta, cosine of theta, and the tangent of the angle. This is where we use our calculators, and we must make sure they either have D in this corner or on the top of the screen for degrees, or the letters DEG short for degrees, to make sure we're working in degrees mode. If you're not sure, then always reset your calculator. So these Casio calculators always shift the number 9 key, 3 for clear all, equals to say yeah we want it, and then cancel that bit, and it's all done, and then we've got D in that screen, so we're working in degrees mode. So we label the triangle up, so theta is the angle we work with and or find, so opposite that is called the opposite length O, The hypotenuse is always the longest side of the right angle triangle, and the adjacent side is the one next to the angle itself. So that's that. The question wanted h, so we tick off h, and the letter they've given the number for is the A. They've given us 12, so we tick off the A's. This is the only ratio that we've ticked off twice, so we're going to use the cosine function. So we write out the rule, replace the values that we know. So we know theta is worth 37 degrees, we know the A value is worth 12 meters, and we want the length of h to j, so we're going to call it the hypotenuse length. We then rearrange this, so h is in the wrong place, so we want h equals, so we bring that across by timesing. So h times the cos of 37 degrees is equal to 12, and then we want h on its own, so we take this across by dividing. It says times there, so we divide on the other side, so h is equal to 12, divide by the cos of 37 degrees. If you don't like rearranging, then these SOHCAHTOA formulas are 3 letters, so we can use the triangle cos theta, A and h. Because it wants h, then we can cover h up, and we can see that we're doing the adjacent length, A, divided by the cosine. The adjacent length was 12, divided by the cosine. So we put that in our calculator, so 12 divided by the cosine of 37 equals, so 15.03 meters. So 15.03 meters. Okay, so that's how we can use trigonometry to work out the missing length if we know an angle and one length of a right angle triangle. Okay, the next question says calculate the size of the angle theta. So again, it's about a right angle triangle, finding an angle with 2 lengths known. So it shouts out to use trigonometry, so SOHCAHTOA. And we go through the process of deciding where the labels go. So theta's here, so this will be the opposite length. Hypotenuse is always opposite the right angle, the longest side. And the length next to the angle itself is known as the adjacent side, A. So in this question we know A and O, so A and O. We've ticked that one twice, so that's the ratio we're going to use for this question. So we write out what the ratio is, so the tangent of the angle theta is equal to the opposite length divided by the adjacent length. We want theta, so we rearrange this by doing the opposite of tangent, which is known as tan to the minus 1, the inverse function of tangent, and we then put in our values. So the O length was 12.3 and the A length was 14.4. Again, calculator question. So shift and tan gives us the tan minus 1 function, and we're doing 12.3 divided by 14.4 equals 3 significant figures is fine, so 40.5. So 40.5, always remember the units, so this is about degrees. Okay, so trigonometry, not too bad a topic if you just learn SOHCAHTOA, labelling triangle by labelling theta. Always label the angle with the symbol theta, so you know where the angle's actually been based in the triangle that you're working with, and then you can label the opposite side correctly, always going in the opposite direction. And the adjacent is next to the angle, and the hypotenuse always being the longest side of the right angle triangle, and the hypotenuse always opposite the right angle. Okay, so we've now got a question involving area, and it wants us to work out the area of the shaded region. These shaded region questions, when you're doing areas and things, they tend to be about a large shape and a small shape. Work out the corresponding areas in this case, take one away from the other, and you're left with a shaded bit. So we'll deal with the large triangle first. So the large triangle, the formula for the area of a triangle we should remember is a half times the base times the perpendicular height. And in this case we can see that the large triangle has a base of 2.3. And it's told us that the whole logo has a height of 2.5, So we know the whole of that is 2.5, so it's going to be 2.5. Again, calculate paper, so 0.5 times 2.3 times 2.5 equals, so 2.875. Again, got units, so write them down, square centimetres. And the small triangle, again, it's formula for the area of a triangle, so half times the base times the height. So they told us the base of this one was 1.1, and then when we read the information it says the smaller triangle is half the height of the large triangle. So the large triangle had a height of 2.5, so the smaller triangle will have a height of 1.25. So 0.5 times 1.1 times 1.25. So 0.6875, and the shaded area then is the big one, take away the small one. So the shaded region is 2.875, subtract 0.6875. So if we take away 2.875 and ignore the negative, so the answer is 2.1875. It hasn't given us any rounding axes to give the answer to, so we'll leave the whole thing, and it's in square centimetres, so remember to always put the units down for all your answers, just in case you get that question where there is no units given and there's a mark for you expected to give it. Okay, so that's working out region areas and areas of triangles. So this next question asks you to work with a prism, and so as soon as we see a prism, then quite often we're thinking about volume, surface areas. So we know the volume of a prism, and again it's a formula that you need to make sure you know, guys. So volume of prism is equal to the area of the cross section times the length of the prism. Now the cross section, remember, is the shape that goes through the whole prism, with the edges then being parallel, and that shape goes through the whole prism. Cut it anywhere and you'll see the same triangle. So that's why it's a prism. So it says for the first bit, calculate the volume. So we know that the area of the cross section is a triangle, so that's going to be a half times the base times the perpendicular height of the triangle, and then we times by the length of the shape. So find the numbers in the question. So the base of the triangle is 4, the perpendicular height measured at right angles is 3, and the length of the shape has been given as 8. And so we've got 2 times 3, which is 6 times 8 is 48, and the units is cubed because they're volume, 3 dimensions, it's in centimetres, so it's 48 cubic centimetres. So remember how to calculate the volume of a prism. Excuse me. Area of the cross section times the length. So if we had a cylinder, we know the cross section is a circle, so pi r squared, the area of a circle, and then times by the height and so forth. The surface area, well, we've got to realise surface area means all the area of every face. So it's the area, so it's the areas of all faces added together. So in this case, we've got 2 triangles, so times 2, and we've got 3 rectangles. So 5 faces for a triangular prism, the 2 end triangles plus the back rectangle, the bottom rectangle, and then the sloping rectangle. So the triangle area, half times the base times the perpendicular height, doubled, there's 2 of those. The base rectangle has a length of 8 and 4, and it's a rectangle, so it's just 8 times 4. The back rectangle has a height of 3 and a width of 8, so that's 8 times 3. And the sloping rectangle has a length of 8 and a height of 5. So 8 times 5. So we work out all of those. So we got this is 12 square centimetres, because it's area, so squares, 2-dimensional. 8 times 4 is 32, 8 times 3 is 24, 8 times 5 is 40. And then we've got to add all those together. So 64, 94, 96, 108. Okay, so that should be the answer for that one. So the surface area is the area of all the faces added together. So if we had to do a cylinder, then we can see that the surface area would be 2 circles plus the rectangle made by folding it all out. So the rectangle has a length of pi d, because it's the same as the circumference, and it has a height of what we call this h, and then you've got your 2 circles, so pi r squared times 2. So for a cylinder, we've got to just remember the surface area is 2 circles, the total surface area this is, times the curved surface area, which is pi d h. Okay, so that's a bit about volume and surface area. Next we're going to look at percentages. So a diamond necklace has increased in value by 15% from its original price. It's now worth what is the original price. So we can see that this is one of those problems where we have the original price, which is 100% of its value. We've found that it's increased by 15%, so it's now 115% of the original. And it's got a new value now of 1380. Okay, and it wants to know what the original price is, so in other words we've got to reverse this process. So this is called the reverse percent. So when we do 115% of an original value, it's the same as timesing by 1.15. So when we want to reverse it, then we divide by 1.15. So 1380 divided by 1.15 equals 1200. So the answer to this question then is £1,200. We should check, if we work out 15% of that, then we get 180. If we add it onto 1200, we get 1380. Okay, so try and avoid the classic mistake on this one, guys. You want to go back to an original price. If you ever want to go back to an original price at the beginning of the story, then it's about reverse percentages. So sketch out a little flowchart of what's going on and then reverse it. Okay, so this next question talks about expanding and simplifying. So expand means multiply out, and simplify, bring any like terms together. So here we've got 7 times 3, and then we've got 7 times a. So 7 times 3 is 21 positive, and 7 times a is 7a, all positive, so the answer will be 21 plus 7a. This one, we've got 2 brackets going on here, 2 single brackets, so we multiply each one out separately and then put the terms together to simplify. So we've got a times b, we've got a times 2, but there's a minus sign in front of that, so it's negative 2a. Here we've got to be careful, it's easier to think of this as negative b times that, which is negative ba, and then we've got negative b times 1, which makes negative b. So what we've got to notice here that BA and AB are the same, so we've got like AB take away AB, so that's gone to 0, so we've got negative 2A and negative B left, so our answer here would be negative 2A, negative B. The next question talks about expanding what we call double brackets when they're next to each other. So lots of methods for doing this. I tend to use the grid, but you can use foil, smiley faces, loads of different methods. Each bracket goes around the outside of the grid, so x and 4 is positive, but we don't normally write the plus sign, but just remind us it's positive. And then we've got x and we've got negative 5, so it's important that we do write the sign this time because we're talking about minus 5, so we treat it as a negative number. And then we fill in the grid by doing the multiplications. So x times x is x squared times something by itself, squaring. X times positive 4 is positive 4x. Negative 5 times x is negative 5x. And then we've got negative 5 times positive 4, which makes negative 20. We then write out each box and then simplify where we can. So no x squareds to cancel here, so just x squared. We've got 4x's take away 5x's, which is just negative 1x, but we don't write the 1, so just negative x. And then we've got negative 20. And okay, and we can check just to make sure we don't make any silly errors. So if we said that x was worth 6, then the bracket would be 6 plus 4, 6 take away 5, so we've got 10 times 1, which is 10. And if we put 6 into this, then we end up with 6 squared, take away 6, take away 20. Well, 6 squared is 36, take away 26 is equal to 10, so it works. Okay, so remember you can check the algebraic solutions quite often by putting a number into substitute at the beginning and then put a number at the end, and you should get the same answer. Okay. This next question talks about a distance time graph, so therefore quite often we're interpreting scales or doing speed or things like this. So we must remember from a distance time graph that lines that are going off at a slope are talking about a constant speed. This one's got a steeper gradient than this one, so this would be the quickest part of the journey and this would be the slower part of the journey. And horizontal lines are telling us that we're stood still, we're not moving. As time goes on, no distance travelled. So the question talks about leaving at 10 o'clock and he's going on a cycling tour. How many minutes did Jeff rest for? Well, this was the rest period from here to here. And we always work out the scale of the graph, so we can see that we've got 5, 10, 15 squares for an hour, so each square is worth 4 minutes. So this would be 10:20 and this would be 10:40. So we started the rest at 10:20 and 11 o'clock, so it'll be 40 minutes. What is his average speed for the last part of his journey? So we're going from here to here, and the average speed is going to be the speed is equal to distance over time. Lots of you like using the triangle. So the question wants the average speed, so we are going to do distance divided by time. So we can see that the distance travelled was from 30 to 50, so 20 kilometres, and the time taken was from there to there, which was from 11 to 11:40, so that was 40 minutes. And it wants the answer in kilometres per hour, so we can do distance 20 divided by the time in minutes, but then we've got to times by 60 because we want hours. So 20 divided by 40 equals times 60 equals, so 30 kilometres per hour. Okay. Alright. Between which times did he cycle faster? Well, this one's got the steepest gradient, so he cycled faster at this part of the journey than there. So that was from 10 to 10:20. So 24-hour clock time being used, so 10 to 10:20. Okay. Right, so this next part of the question then talks about a solid shape made from centimetres cubed, the plan, the side and the front elevation. How many centimetres cubed were, right, okay, so alright, so the information tells us then about the shape. Okay, so this front elevation is suggesting that the shape is of this type. So that's the 3D image. The plan view is telling us that it was 4 centimeters, 5 centimeters by 3, and the 3 was the whole. Okay, the side elevation is coming from there. The front elevation is coming from there. The plan elevation is coming from there. Okay, so let's have a look. The side elevation is suggesting that that was 3 centimeters, and the height of the whole shape was 4 centimeters. Okay, that's what the side elevation tells us. The front elevation is telling us that this was 4 centimeters, and it was telling us that this was 3 centimeters. Okay. So that was 3, and the plan is telling us then that the whole of this was 5. So the front elevation, so I misread that, that's 5, isn't it? And that was 3, and that was 2. And then that would make the plan 5 by 3. Okay, that's it. Okay, so we've got all our dimensions on our shape, so we've just got to work out how many centimeters cubed there are. So this is like a prism, so to me I'd work out the number of cubes along this side, and then I'll just times by the length. So we can see that the number of cubes on this length here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 2, 4, 6, 8, 10, 12, 14. Okay, so there's 14 cubes in this bit, and we're going 3 deep. So the number of cubes then is 14 times 3, 30, 12, 42. So 42 centimeter cubes are used. Okay, so that's how that kind of question could be done, by trying to draw the 3D image of what this elevations are showing you, and just getting the numbers in the right place, and then thinking about how many cubes make up by thinking about the dimensions of the front elevation times the depth of the shape. Okay, so this question talks about a back-to-back stem and leaf diagram, and basically we've got to remember, reading a back-to-back stem and leaf diagram, we're coming this way, so this number here, for example, means 59, and so for test B we're always reading in that direction, and for test A we're reading in that direction. So for example, this number here is 75. Okay, so this is in percentages, so this was marks in a test. Compare the distributions. When you've got stem and leaf diagrams, you need an average. So when you're comparing, you need an average and a measure of spread. From stem and leaf diagrams, we use the median average and the range. You can use the mean average if you want to include everything. That tends to be a better average, but at the end of the day the examiners are just looking for you to make a comparison of an average and spread. So from stem and leaf diagrams, the easiest average to calculate is the median. It tells you something about the middle of the day, trigonometry outliers, and the easiest measure of spread is the range. So let's go for it. So a little table, test A, test B. So we'll have the median and the range. Okay, so for test A, there was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 people in there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, okay, 10. So the middle's going to be there because we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers before it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers after it. So 74, 75, the middle of that is 74.5. And the range, well, the highest number was 90 and the lowest number was 62. So it's going to be 90, take away 62, which is 28%. Okay, for test B, we can see that there was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It should be the same, yeah, 20. So we need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so the middle is going to be there. So that's between 69 and 70. So halfway between those is 69.5%. And the range, well, the largest is 79 and the smallest was 52. If you take those away, we get 27%. 79, yep. 80, 90, yep. Okay, so compare means we've got to write some sentences. So we've got our data to compare. So we can basically say that test B median average was lower, suggesting typically the percent scored was less on average. Okay, always compare in the context of the question. And then the range, the ranges for both tests were similar, showing a similar, I'll use the word similar again, an equal spread of the results in both tests. Okay, so that's how we would do a comparison question using data, and we would compare an average and a measure of spread. And in this case, we'd calculate the median because it's a stem leaf diagram, and the range. If it was just a list of numbers, then we'd probably calculate the mean average and the range. Very rare you use the mode unless you're talking about buying things in shops and you're looking at what sells the most, then you might compare the mode averages. But it's usually the median, ignoring outliers, or the mean, including all the data. Okay, the next question goes on and says factorise. So we recognise that means put things into brackets, and then we've got to decide is it a single bracket or a double bracket. But we look at this and we can see that both of these terms have a common factor of x. So the highest common factor would be x, and dividing both of these by x, we get x and 7. Expand, multiply out, so we've got x times x, which is x squared, and we've got x times 2, which is 2x, so both positive, so it'll be x squared plus 2x. Factorise completely, so we're looking for the common terms. Yep, what common terms? So it's going to be a single bracket, and the numbers 2 and 4, highest common factor is 2, and y squared and y, the highest common factor is y. Divide that by 2y, we're left with a y, and divide that by 2y, and we're left with 2. Take away, so take away, check it works, 2y times y, 2y squared, 2y times 2, 4y. So 2y, y, take away 2. Always remember we look for the highest common factor when we're doing single brackets, so that we can put the highest common factor outside, divide each of the terms by it, and we end up with what's left in the bracket. Okay, so that's examples of factorising.